Welcome back to Aurora Tech Channel. Today, I will review the Q1 Pro, which is the latest generation clipper machine from QiDi. It has a 245 by 245 by 240 millimeter print volume with a maximum nozzle temperature of 350 degrees Celsius and a maximum bed temperature of 120 degrees Celsius. The printer frame is made of metal with a fully enclosed actively heated chamber that can reach up to 60 degrees Celsius. The extruder boasts a new design with an 8.9 to 1 gear ratio, and it comes with a hardened steel nozzle, allowing it to print abrasive filaments like nylon carbon fiber right out of the box. The bed leveling and auto Z offset are done by 3 strain gauges underneath the bed, complemented by another inductive sensor inside the print head. Besides the turbo part cooling fan inside the print head, it also has an auxiliary fan for extra cooling. The motion system uses linear rods on all axes, with dual Z axes driven by 2 independent stepper drivers and motors. Additionally, the TMC 2240 silent stepper drivers support sensorless homing. The claimed top speed is 600 mm per second with a 20,000 mm per second squared acceleration. It uses Clipper firmware with some minor customization. The motherboard is an MKS Pi with a Cortex A53 1.5 GHz quad-core processor. There's 32 GB of eMMC instead of the 8 GB commonly seen on most Clipper motherboards, and there's 1 GB of RAM. The Fluid Web interface can be accessed using a browser, and it's also integrated into their QiDi slicer, which is a fork of the Prusa slicer. It also has a mobile app, which is basically the mobile version of the Fluid Web interface. For other features, it has a built-in 1080p Full HD camera and a filament runout sensor with a filament tangle detection feature. It also has a second spool holder to let you choose whether you want to mount the spool from the back or at the side. The MSRP of this printer is $599. It's currently on pre-sale for $469, so for less than $500, the hardware specs seem really good. I would like to thank QiDi for sending us this machine to review and for sponsoring today's video. And with that, let's get started. The printer box is not that big compared to the last generation X-MAX 3 and X Plus 3. There are 2 large pieces of styrofoam, and the whole machine is inside a bag, so you can just lift it up. Everything is in one piece, so you just need to remove the protective materials. Once the machine is on, select language. It then reminds you to remove the zip ties and a few screws used to secure the bed during shipping, and those screws are also labeled. While the platform is moving up, you can insert filament. I will just mount a spool at the back. It requires you to heat up the nozzle using the screen. Once the temperature is reached, we can press the down arrow to load some filament. Surprisingly, the setup wizard just ends like that. It seems we still need to do input shaper and auto bed leveling, so let's go to the settings menu and see. Inside the menu, we have auto bed leveling, input shaping, and platform calibration. Let's start with auto bed leveling. It also requires you to manually heat up the bed. Then the print head will move to the back of the printer and wipe itself on the cleaning block. The good thing is it has its own toilet, so you don't have to collect the filament poop from the back. It will level both sides of the lead screw, followed by a probe at the center of the bed and a round of 25-point auto bed leveling. Then we will do input shaping. Finally, I'm not sure what this platform calibration is about, but let's see what it is. It asks you to insert the paper to set the Z offset, but since this machine is supposed to set the Z offset automatically, I'll just skip it. It then asks you to adjust the manual level knobs, but as you can see, there's strain gauges at the corner and there are no turning knobs, so I will also skip it. I will just skip all 3 corners. I'm not sure if it's gonna work, but I will just start a test print, starting with the 3D Benchy sample G-code. The estimated time is 18 minutes, so let's print it and see how it performs. It will clean the nozzle again, then probe the left and right side of the bed to level the lead screws, followed by small area bed leveling similar to the Prusa MK4. Once the temperature is reached, it's going to print 2 purge lines on the left and at the bottom of the print, exactly like the Prusa MK4. I will let it print a few layers and reach the top speed, then do a sound test. The sound meter is placed 6 inches away, and when the door and top cover are open, the sound level is around the mid-60s in decibels. When it's fully enclosed, the sound level stays in the mid to high 50s, which is pretty quiet. The print finishes in 21 minutes, and the layers on surface both look good. It's slightly better than most fast benchies printed right out of the box from a fast clipper printer. The cooling at the front is also fine, and overall it's a decent fast benchy. Let's start some of our benchmark test prints. First, I will print the Honeycomb box to test the retraction of the extruder. The extruder can print a tiny bit of filament and move to the next spot without issues, and with just some stringing, so I will just let it finish. It took 2 hours and 1 minute to finish, and the printing time is faster than the average 2.5 hours. The result is good. All patterns can be printed without any broken honeycombs, and the retraction is also good with minimal stringing. When compared to the previous version, like the QiDi X-MAX 3 and X-Wet 3, the stringing of the Q1 Pro is slightly better. When compared to machines that get better results, this Q1 Pro is still one of the best. Next, I will try the number slider. The purpose of this print is to test the clearance. The clearance of the first layer is good, as we can clearly see gaps between tiles. The print finishes in 2 hours and 24 minutes, which is also slightly faster than the average of a 2 hour and 45 minute to 3 hour printing time. The top is alright with just minimal stringing. The clearance should be good, as you can see the tiles on the right have already dropped. The bottom is also good, as the gaps between the tiles are clear. Let's check the clearance, and all tiles can move freely. Up next, I will try a tolerance test by printing my own simple geometry model and see if the parts can fit with each other. The print finishes in just 1 hour and 40 minutes, which is the fastest result compared to the average 2.5 to 3 hour printing time. For the square, it can clear all the way from 0.225mm to 0.05mm, which is perfect. For the cylinder, it can also clear all the way up to 0.05mm. The text on the surface is not the best, but the tolerance is one of the best. Then, I will try a decorative print, the Robo Alpaka from Prusa. The print finishes in 4 hours and 17 minutes. The speed is average, and the surface quality looks pretty good. Let's take a look from all 4 angles and do some comparisons. Compared with the Flashforge 5M Pro, which is the fastest corresponding machine tested so far, the surface quality is similar, but the text on the Flashforge is cleaner. When compared to the BambuLab P1P, the printing time is almost the same, and the surface quality is also very similar, but the text, once again, is not as clean as the P1P. Compared to the Creality K1C, the Q1 Pro is slightly faster, and the surface quality of the K1C is slightly better, but the text printed on both machines are not as good as the Flashforge 5M Pro and BambuLab P1P. Compared to a bed stinger like the Embassy V3, the Q1 Pro is faster with better surface quality and even cleaner text. So, the Core XY Q1 Pro is a clear winner. Next, let's try some different materials, starting with a TPU wallet to test the extrusion. This Eryone TPU is super easy to print, so even the stock Bowden setup can handle it pretty well. I will print at 62.5mm per second. The white LEDs on the frame of the printer make the surface look bad, but that's not the case. I will remove it from the printer when it finishes and show you the actual result. The extrusion is perfect, the bottom layer looks good, and the side and the top also have no issues. Then, I will try some ABS. I will max out the X-axis and print a 240mm long ABS crate. The flow rate for the default ABS profile is limited to 17mm cubed per second, which is about 212mm per second in terms of print speed. But I guess it won't make any difference, even if you set the speed to 300mm per second, as these patterns are small, so there's no room for the print head to accelerate to a higher speed anyway. I didn't turn on the heated chamber, I just let the printer stay fully enclosed, and the internal temperature can still maintain around 40 degrees Celsius, which is enough for ABS. This large ABS crate finishes in 7 hours and 29 minutes. There's some stringing but no warping. The corners of the crate printed on an open frame printer would crack, but with the stable ambient temperature, I don't see any layer cracks on this print. Next, I will print a large PETG trash can. We will also test out the first layer sheet with PLA, but it seems this PETG first layer also looks awesome. However, the filament runs out when printing this final part, and the printer pauses and shows the message. As I'm running out of flat PETG, I will just continue with gray PETG. The trash can isn't too bad, but I will just print another one with the gray color filament. In fact, the gray color PETG is not as shiny as black, so the layers actually look better. Unlike the bed center, which will show more winging at the top of the print, it delivers very consistent results from bottom to top. Let's try the PLA sheet and see if the first layer out this machine is that good. There's a first layer sample G-code here, so I will just print it out. The print finishes in 24 minutes, and the result is perfect. As the maximum temperature of the nozzle can reach 350 degrees Celsius, and the bed can reach 120 degrees Celsius, I will try some different nylon carbon fiber, starting with the normal one to print a phone tripod mount. This QiDi PACF is printed at a 255 degrees Celsius nozzle temperature and a 70 degrees Celsius bed temperature. The print actually stops as the filament spool was stuck inside the filament dryer, but the machine has a filament tickle detection feature, so when the roller inside the filament sensor isn't moving, it will pause the print as well. So I will fix this and the print resumes. This is a new version of the phone tripod mount that I redesigned in Vision 360 as I found the previous one breaks when the tripod falls on the ground. This is a beautiful part. The layers are clean and the threads and the knob fit perfectly. I also changed the bottom to the Arca Swiss standard plate so the 1/4-inch screw is no longer needed to switch between tripods. Then I will print the same model, a camera lens hood using 2 different nylon carbon fibers, starting with the regular one. This print finishes in 31 minutes and I will show you the result later. Now, I will use this high-temperature nylon carbon fiber from Phaetus. This material can resist from 121 degrees up to as high as 192 degrees Celsius. The recommended printing temperature is 300 to 320 degrees Celsius, as when you print faster, you need a higher temperature or stronger extrusion force. So, I will just set the nozzle temperature to 320 degrees Celsius and print at the same speed of 187.5 millimeters per second. This print took 3 minutes longer to finish, and the surface and layers of both prints look good. However, the gaps of the regular nylon carbon fiber are a bit close to each other. It may affect the fitting while the high temperature looks just like the STL model. From the inside of the hood, they both look good. As expected, the regular PACF also fits, but it's a little bit tight while the high-temp PACF fits better. However, when I look into the viewfinder, I finally understand why no one is making the hood for this Arca C3 camera. If a hood is added, it will block 1/3 of the viewfinder. But this is just a comparison of regular and high-temp PACF. Besides the fitting and better temperature resistance, the high-temp one is also stiffer and feels more like glass fiber than carbon fiber. Finally, I will print a cable holder with polycarbonate. I will set the print speed to the same 187.5 millimeters per second. The print finishes in 1 hour and 29 minutes. The structure of the part looks okay, and only the surface near the screw holes is not that clean. Unlike printing PLA, the cooling is off during the whole print with PC, so the overhanging areas may not look as good as PLA, but that's fine as we use PCs mainly for functional parts because of their stiffness. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The Core XY kinematic and the linear rods motion system is working well. Even when printing at high speeds, it may not be the fastest machine, but it's definitely one of the fastest with decent print quality. 2. The heated chamber is useful when printing with filament that requires a stable ambient temperature. It may not be as useful during the summer, but in the winter, my cold garage can't print ABS well, even with an enclosed printer without the heated chamber. The chamber fan itself is powerful. I turned off the heated bed and was able to solely use the chamber fan to boost the inner temperature to 60 degrees Celsius. There's another exhaust fan at the back. When the temperature is higher than expected, besides turning off the heated chamber, you can also use it to exhaust heat outside. 3. The extra 50 degrees for the nozzle and 20 degrees for the heated bed is handy. It can print a slightly broader range of filaments. Even when printing the same filament, the higher nozzle temperature allows it to print faster. Although it may not be able to print materials like PEEK which require an extrusion temperature from 370 Celsius and a bed and chamber temperature of at least 140 degrees Celsius. But as a 1 kilogram of peak filament is even more expensive than this printer, I definitely don't expect a machine at this price point to be used for that purpose. 4. The AutoZ offset and bed leveling are working great. It includes a PLA sheet test print in the sample G-code, which means they're confident with it and they definitely nailed it. The idea from Prusa to just probe the area as large as the print is also good. 5. The slicer is a skinned Prusa slicer, but it seems it also updates frequently. It works better than most skinned Prusa slicers out there. The network feature also lets you manage multiple printers in the slicer over your local network without using any third-party cloud service. Normally, I don't like to keep many different slicers on my computer, but I would keep this QiDi slicer and use it with my other QiDi machines. Now for the cons. 1. The menu is confusing. Even though it's AutoZ offset, it still has a bunch of options right under the main menu that make it seem like you need to set everything manually. It would be better to put those buttons under advanced options. 2. The way it unloads filament differs from most other printers. Unless you follow exactly what the screen says and cut off your filament manually and let the extruder push out the remaining filament instead of pulling it out like you would normally do on most other regular 3D printers, filament residue is very likely to clog the extruder. If that happens, you have to open up the extruder and remove the filament residue manually. 3. The file list under the print menu used to be random, but after the latest firmware update, it changed to sorting files alphabetically. Since the machine has 32 gigabytes of storage, users can store hundreds of files on the machine, making it difficult to find a specific file. It would be better to give users the option to select how the files are sorted, by upload time, by last print time, alphabetically, file size, and even allowing them to just search for a file. That would be more practical. 4. For PEI sheet alignment, it only has one stopper at the center. It would be better to add 2 more stoppers at the corners as well. 4. They made a simple app that shows the Fluid Web interface, but the default language of the app is Chinese, so unless you know a little bit of Chinese like me, you should be able to go to the settings menu to switch the language, but if not, it's pretty frustrating once you just installed the app. When using the stock firmware, the app can't find the printer. When I tried to download the latest firmware, the file was blocked by Windows and the Chrome browser and claimed it contained a virus. Although their GitHub page mentions this issue and requires you to manually disable the firewall or antivirus to download it, I haven't seen the same issue with any other 3D printer, even for those using the same MKS Pi motherboard. After updating to the latest firmware, the app finally works. I'd say QiDi should focus on more polishing for their software, firmware, and apps. In conclusion, the hardware of the QiDi Q1 Pro stands out as the best in its class. Priced at $469 during the pre-sale period, it undeniably offers the best value among fully enclosed 3D printers on my recommendation list. However, I'll need to wait and see if the price stays the same or changes after the pre-sale period ends before making my final decision. If it stays at $469 or doesn't move too far from that, and I can see screen firmware and software updates that make things work smoother, I would very likely award this machine the title of the best value fully enclosed high-speed 3D printer. Overall, I'm pleased with this printer's performance, print accuracy, and speed. If you have experience in 3D printing and want the ability to print a broader range of engineering-grade materials, you'll also be satisfied with the Q1 Pro. I have included its link as well as the link to my website, aurora-techchannel.com, which also provides hourly updates on the prices of over 150 machines with detailed specs for easy comparison. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching and I will see you next time.